All right, so here's going to be the key for solving logarithmic equations. So I'm just going to do the odds. Um, so here we got two logs set equal to each other. All right, so this is going to be easy because the bases are the same. And so if the bases are the same, all we need to worry about is making what's in the parentheses the same. So really, we're just worried about solving 8 minus 5x equals 5x minus 2. All right, and so uh, we add 5x to both sides. And we add 2 to both sides. So on this side, 8 plus 2 is 10. 5x plus 5x is 10x. Divide both sides by 10, and you get your answer, x equals 1. Now, when you are solving logarithmic equations, you have to check your answers because obviously we know that whatever's in parentheses has to be positive. All right, and so you just got to make sure when you plug in 1, right, you get positive 3 there, you get positive 3 there, it works. Right? If it was to ever give you a negative, right, it wouldn't work because we know that our domains, our x's are limited to what make these positive. All right, so on this worksheet again, um, just here, like I don't know why this program that makes these worksheets uh, does not put parentheses around everything. They only put parentheses around if there's something being added or subtracted, but it should really be all the time there. So when you see number 2, you know that's in parentheses there. So number 3 is going to be the same as number 1. We have same bases, but this one looks like we're going to end up with a quadratic. X squared plus 78 equals 18x minus 2. Okay, so again, we've been solving quadratics for a very long time. We know whenever we have a quadratic, we must set it equal to 0. So I'm going to subtract 18x from both sides and add 2 to both sides. And that way, I get everything equal to 0. So I get x squared minus 18x plus 80 equals 0. Now that's factorable. What multiplies up to 80 and adds up to negative 18? That's going to be x minus 8, x minus 10. So I get 2 answers. X equals positive 8, x equals positive 10. And then we have to check to make sure that they're both positive when you plug them in. So you plug in 10, you get 100 plus that 178, right? 180 minus 2, 178. So 10 works. I plug in 8, I get 64. Right, plus 78, that's positive 18 times 8. So both of these are going to work. I'm going to get 2 answers here. All right. With number 4, again, you would just make sure you divide by negative 3 first. And then rewrite it. You could also bring it up there first if you wanted to. But then you'd be solving with the cubic. Just be easier there to divide by negative 3 first. All right, number 5, I'm going to add 2. All right, again, I'm trying to get the log by itself here to solve for p. So I got to isolate the log first. So I add 2 to both sides. Get log base 4 of 5p plus 8 equals 1. And now I can rewrite this as an exponential. So 4 to the first equals 5p plus 8. Obviously, 4 to the first is just 4. I subtract 8 from both sides, you get negative 4 equals 5p. So p equals negative 4/5. And again, just double check. This cannot be negative. So if I plug that in, I get negative 4 plus 8, which is positive 4. So that does work. There you go. All right, number 7. Okay, now I've got an issue. All right, there's 2 logs, so I can't just rewrite it. So I've got to condense these. Okay, so to condense this, um, I'm going to need to use the property, which again, you got to remember, these are exponents. All right, when did you add exponents? When you were multiplying. Um, you multiply exponents um, together when it's power to the power, but you add exponents together when you're just multiplying bases, right? So here, this is the same as log, right, base 6x equals 1. Okay, I just multiplied these two together. All right, and so now the base is 10 here. So it's 10 to the first equals 6x. Divide both sides by 6. X equals 10 over 6, or 5/3. And again, that's positive. You plug that back in. Now on this one, you could have gotten away with not doing that, because you could have just subtracted 1. You could have done 1 minus log 3, because log 3 is just a number. All right, so you could have um, converted that to a decimal first. All right, number 8. Okay, so here again, you could convert this to a decimal first. That's a decimal. You could subtract it there. There's lots of different um, strategies you could do here. But if we just condense this together, get log base 7, you're going to multiply. You got to make sure you distribute 4x minus 40 equals log base 7, 58. So now, just like the first question we did, they got the same basis. So just set the parentheses equal to each other. 4x minus 40 equals 58. Add 40. 98. Divide by 4. Okay, as a decimal, it'd be 24.5. Okay, or 49 over 2. We leave it as a fraction. All right, I wasn't supposed to do that when I was even. All right, so here again, we got log of 3x squared plus log 3. So I'm just going to multiply those together to get 9x squared. And so you get 10 to the third equals 9x squared. 10 to the third is 1,000. Divide by 9, you get 1,000 over 9 equals x squared. Square root both sides. And you get x equals plus or minus 10 rad 10 over 3. And those are both going to work, the negative one too, because when you plug it back in, you square it, it becomes positive. So no matter what here, okay, the only thing x cannot be would be 0 on that one. Okay, last one, natural log of x plus 3 minus natural log of 3 equals 4. Okay, multiply, or now it's division because it's subtraction. So it's natural log of x plus 3 over 3 equals 4. All right, because remember when you're dividing powers, you subtract exponents. So if you're subtracting logs or you're subtracting exponents, you're dividing. Okay, rewrite that. The base is e, so it's e to the fourth equals x, it's an equal sign, equals x plus 3 over 3. Multiply both sides by 3, you get 3 e to the fourth equals x plus 3, and then subtract 3. 3 e to the fourth minus 3 equals x. Okay, and so there's your key for this one.